everyone, I am Madam Rosmaya. In this video, we are going to discuss on PU physics topic in semester 3. So I'm going to give you tips to use the derived formula in Doppler effect. So recall what we have learned before. What is Doppler effect? So by refer to the animation given here. Okay, this animation illustrating how the Doppler effect causes a car engine or siren to sound higher in pitch when it is approaching than when it is receding. So the red circles represent the sound wave. Okay, the Doppler effect is the change in frequency of a wave in relation to an observer who is moving relative to the wave source. So it is named after the Austrian physicist Christian Doppler, who described the phenomenon in 1842. So the formula is F prime equals to V plus minus VO per V plus minus VS bracket here times F. So F prime is the apparent frequency, F is the actual frequency of sound waves, VO is the observer velocity, VS is the source velocity, and V is the velocity of sound waves. So we don't discuss the detail on how we get this equation. Okay, so in this video, we are going to discuss on how to use the sign of plus minus here for observer velocity and source velocity. So we are going to use this form, okay, of arrow and SO minus, okay, S to O towards O minus, S represent source, O represent observer. Okay, then if look at from O here, observer move away from source, minus, and S move away from O, or O move towards S, so we use plus. So let's discuss this in detail. Okay, S to O minus. So that's mean the source of sound moving towards the observer. So that's mean VS, the source velocity is negative, so minus VS. Okay, next refer to the same relation here. O, observer move away from source, so source stationary, so observer move away from source, so that's mean VO is negative. Okay, for the below relationship between S and O, so S is source. So if the source move in this direction, means away from O, observer. Source move away from observer, so that's mean positive VS. VS is positive. And look at the observer here. So observer move towards the source. Okay, the observer move towards the source. So also the sign for observer velocity is positive. So that's mean plus VO. Okay, so let's try example. A sound source of frequency 500 Hz moves with a speed of 40 meter per second. If the speed of sound in air is 340 meter per second, find the apparent frequency of source if the source moves towards a stationary and B away from a stationary observer. So given that the frequency of the sound source is 500 Hz, F, and 40 meter per second. So this is the speed of the sound. So the speed of sound in air is 340 meter per second, represented by the letter V. And the apparent frequency that we are going to determine in this question is F prime. So stationary observer means the VO equals to 0. Okay, from for A question, towards a stationary observer. So that's mean the source sound source move towards a stationary observer. So the F is 500. F is 500. Then the speed of sound is 340. So we substitute into the equation here. Okay, now we are going to determine the sign for the observer and the source. So the observer is stationary, so we substitute here 0. So no need to write for 0 here actually. So plus or minus Vs, the source velocity, sound source velocity. So the sound source move towards the observer. So that's mean the first one. So the source move towards the observer. So that's mean minus Vs. So here we put minus Vs, and Vs is given as 40 meter per second. Okay, so we calculate, we get the answer 567 Hz. Okay, then for B, away from the stationary observer. So the sound source move away from the stationary observer. Okay, so again from the equation just now, we substitute 500 and 340. Okay, for B, this one is F. Okay, now plus minus the observer, stationary observer is 0, so no need to write. Okay, so for the sound velocity, okay, the sound source velocity, so we use this one because away, so S away from O, so the sound source away from the observer, so means plus means positive, plus 40 meter per second. Okay, given the Vs is 40 meter per second. So you calculate this, you get 447 Hz. Okay, so next we try second example. A car moving a constant speed of 20 meter per second towards a stationary policeman who blows a whistle. The frequency of sound produced by the whistle is 425 Hz. If the speed of sound in air is 340 meter per second, find the apparent frequency of sound heard by the driver of the car when the car approaches the policeman. B, when the car moves away from the policeman. Okay, so what is given in the question? The car moving at constant speed 20 meter per second. So this is the speed of the observer. Okay, the policeman blows a whistle. So the whistle here is the sound source. So Vs is 0 because stationary. And the frequency of the whistle, sound of the whistle is 425 Hz, F. So the speed of sound in air is 340 meter per second, so V. So apparent frequency is what we're going to determine, F prime. And the car, for A question, okay, so the car approached the policeman. So that's mean observer approach the policeman. Okay, from the equation, apparent frequency, so we substitute frequency first, 425, and the speed of sound is 340 meter per second. So we are going to determine the sign for observer velocity and sound source velocity. So the source velocity whistle is stationary, so here 0, so no need to write also can here. Okay, now left observer velocity. So for observer velocity, so the car approached the policeman. So that's mean the below relationship, S and O. So the observer, the observer approached the policeman. So represent by the observer, represent by the man here. So approach the policeman. So this way means positive. Okay, the observer approached the policeman. Observer, the car approached the policeman. So plus 20, VO is given as 20. So plus 20 into the equation. Substitute into the equation, plus 20. So the answer is 450 Hz. Okay, for the B question, the car moves away from the policeman. Okay, so as usual, we substitute 425 and 340 first. Okay, and the Vs is 0, so don't need to write. Okay, for the observer, this time the car moves away from the policeman. So the car is the observer, so the first one, the car or observer move away from the sound source, policeman. So this one, so O move away from the sound source, so it's minus VO. So we put here minus 20 meter per second. Okay, we calculate, we get the answer 400 Hertz. Okay, so we try the third example. A police car parked by the roadside has its siren on. So the frequency of the siren is 1000 Hz. A car is traveling at a speed of 20 meter per second on the same road. The police car then goes after the car at a speed of 25 meter per second. What is the apparent frequency of the siren heard by the driver of the car when the police car is behind him? And B, when the police car has overtaken him. So we use the speed of sound in air, 340 meter per second. So we are given the frequency of the sound source, and the car is traveling at speed 20 meter per second. This one will be observer velocity. And the police car has the siren on, so that means the police car, the source of the velocity is 25 meter per second, Vs. So F prime, we are going to determine the F prime. Okay, the speed of sound V, 340 meter per second. Okay, for A question, the police car is behind him. So we substitute V and F first. F is 1000, V is 340. Okay, so now both observer and source are moving. So we are going to determine the sign plus or minus for the observer velocity and for the source velocity. So the police car is behind him, so that's means the source is the this is the Vs, the Vs. Okay, so to imagine the police car here as a source and the car here as the observer. So the police car behind, the police car here behind the car, the source. So the policeman is chasing the car, this car. Okay, so that means the car is moving away from the observer. So the first one, O, moving away from the source. So that means minus VO. So you substitute into here minus 20. So VO is 20. Okay, so minus 20. Okay, next for the source. So now the B question is overtaken. The police car sorry, we still question A, not B. Okay, so the police car behind him, okay, for VS, chasing the car. So means the source, I repeat, so that means the police move towards the source, the observer. Okay, because the policeman chasing the car. Okay, so it move towards the O. So we use the first relation. So means minus, and negative means minus Vs. So you substitute here minus 25. So 25 given here. Okay, for Vs. So minus 25. Okay, the answer is 1016 Hz. Okay, that's how we use this relationship S and O, by using the arrow. Okay, next question B. The police car has overtaken him. So the police car has overtaken him. That means the police car is in front of the car. So we substitute first 1340. Okay, now the sign for observer and the source. So this time the police car is in front of the car. Okay, the source is in front of the car. So the source, the car is now moving towards the policeman, the source. So that means the VO is positive. Okay, because the police car has overtaken him, so in front. So it's moving towards the observer, moving towards the sign, the source, the siren, the source from the siren of the car. So positive. So means positive 20. Okay. The speed of the car is 20. Okay, plus 20. So for the source is moving away. Okay, so here refer to the S here, moving away from the observer. So that means the Vs is positive. Refer to the arrow here, S is moving away from the O. Siren source the sound source moving away from O. So Vs is positive. So that's mean plus 25. Okay, so now we calculate, we get the answer 9,086 986 Hertz. The answer is 986 Hertz. Okay, so that's all tips on how to use how to determine the sign for observer velocity and the source velocity, only by referring to this relationship between S and O together with arrow. So S towards O minus S, O moving away from S minus. Okay, for the below relationship, source moving away from O plus Vs, observer moving towards S plus VO. Okay, that's all for the video. Thank you for watching, and if you like this video, please subscribe.